Welcome back to Rani AI Labs. I am Ashutosh. In last video, we covered the theory what an AI agent actually is. A combination of a brain, some hands, a notebook and a loop. Today we stop talking about it and actually build one. By the end of this video, you will have a real working AI agent running on your laptop for free using LangChain and Groq. So today I am keeping this one deliberately simple. No huge project, no complicated setup, just enough code to see agent loop happen with your own eyes. So let's go. So here's the plan. We are building an agent that can do two things. One, add two numbers together and to count how many words are there in a sentence. I know it's not exactly that groundbreaking, but that's the point. You will see the agent decide on its own which tool to use and when. And once you understand this, you can plug in literally any tool like web search, a database, a calendar, or anything else. The mechanics remains the same. So now let's discuss about the project setup and how to set it up. So the first thing in the setup is to get the API key. So to get the API key, simply open any web browser and in the search bar type console.groq.com and be careful, it's GROQ, not GROK. Okay, and press enter. So as you can see, the Groq website has been opened in front of you. So here you can see the tab like playground, API keys, dashboard, docs, etc. Click on API keys and here you can see a create API key button. Simply click on it and give any name to your API key. So I am giving it name as first agent. And so from here you can also set the expiration of your API key. So we will keep it as it is. So our API key will not expire. And click on submit button and wait for some time. So as you can see now the API key is being displayed. So it also giving us a gentle warning that copy it now as it will not display again. So simply copy this API key and paste it somewhere like uh, notepad or any word document for later use. So simply click on done and that's it. Your API key is now ready. So close the web browser and now let's set up the folder for our AI agent. So open this PC and in this PC you can choose any drive of your choice. I am choosing uh, new volume D. So inside that create a new folder and name it as first agent and open it. In your case this folder will be empty but I have already created two folders so you will have an empty folder. So now inside this empty folder, right click and click on open in terminal. It will open the Windows PowerShell and here you can see the name of the drive in which the folder is there and the folder name. So now type here a command code space and dot and press enter. This will launch VS Code if it is already installed in your system. So as you can see, the VS Code is now open and now here we have to do few important things. Uh, Here you can see a side tab. Simply click on folders to see the folder name. So now the first thing we have to do is create a virtual environment. So to create a virtual environment, you will need a terminal. So to get a terminal, here above on the top left hand side, you can see a ribbon. From that ribbon, click on the terminal tab and a drop down will appear. Here you can see a new terminal option. Just simply click on it and you can see a PowerShell terminal has been opened. If you don't want to use the PowerShell terminal, you can choose any terminal of your choice like Git Bash, Command Prompt, Azure Cloud Shell, etc. But I will be using PowerShell. So the first thing to do in this terminal is to create a virtual environment. So to create a virtual environment, simply type this command python space hyphen m space venv, which is a short form for the virtual environment space dot venv. So this .venv represents the desired name you want to give to your virtual environment. In our case, I have set it as .venv to keep things simple. And after writing this command, simply press enter. You can see in your parent folder, that is the first agent, the virtual .venv virtual environment folder appears. So as I already created it, I will not do it again. So after creation of virtual environment, we need to activate it. So to activate the virtual environment, simply type this command .venv, which is the name of our virtual environment, backslash scripts, for which the S is capital, again a backslash activate .es1 and press enter. It will automatically activate your virtual environment. So to check whether the virtual environment is active or not, you can see here in front of our drive name, you can see in brackets in green color .env, which tells us that now our virtual environment is active. Now inside this activated virtual environment, we have to install our two dependencies. So to install the two dependencies, simply write the command pip install langchain space LangChain Groq, which will be required for the development of our agent, and press enter. After pressing the enter, the Python package installer will take some time to install the dependencies. As I have already installed both dependencies to save the time, we will now move towards the actual development of our AI agent. So after the dependencies get installed successfully, come to your parent folder, and from here you can see this new file button. Simply click on it and give it name as first underscore agent dot py. So here, as I already created it, this file will hold our agent code. So now let's build our AI agent piece by piece and understand each and every line of code. Now let's first understand the imports. Let's go one at a time. Import OS. This is just a standard Python library, nothing LangChain related. We are using it purely to set an environment variable in a second, which is the standard and secure way to hand an API key to a library without hard coding it deep inside some function call. The second import, from LangChain Groq, import chat Groq. Notice this comes from a separate package, LangChain Groq, not the main LangChain package. That is actually a really useful thing to understand about LangChain as an ecosystem. The core LangChain package stays lean, and each model provider like Groq, OpenAI, Anthropic, whoever gets its own small connector. So here, the chat Groq is that connector. It's the class that knows how to talk to Groq servers. So now the next import is from LangChain.agents import create agent. This is the star of the show. It's a single function that will assemble everything we talked in video 1, the brain, the hands, notebook, and the loop, into one working agent. We will unpack exactly what it does when we get there. The last import, from LangChain core.tools import tool. This is a decorator. If you are newer to Python, a decorator is just a special kind of wrapper you place above a function using the symbol, and it changes how that function with you have behaves without you having to rewrite it. Here, tool takes an ordinary Python function and dress it up so the agent can understand and call it. We will see this in action in a minute. Next thing is the API key, which we have pasted in our notepad. So this line sets what's called an environment variable. Basically, a piece of configuration that lives outside your code in the environment your program runs in. So this Groq API key is actually works like as a key, uh, which provides the code access to the LLM which we want to access from the Groq cloud. So please remember one thing. When in the production system, one should never commit this API key or other secrets to the GitHub. So, the good practice is to create a .env file, and you have to store all the secrets like API keys in there. So now the fun part begins. The tool, the hands of our AI agent. So remember from video 1, tools are what let the agent do something instead of just talking. Now let's break down each tool in detail. So the @tool line. This is the decorator we just imported. The moment you put this above a normal Python function, in our case, which is the def add numbers. So the LangChain wraps it so an LLM call see it, understand what it does, and decide to call it during the agent loop. Without this line, it's just a regular Python function. The agent has no idea if it exists or not. So now let's understand the function signature. So the function add numbers inside the brackets a floats and b float and output float. These float bits are the type hints. They are telling the Python and the agent exactly what kind of input this tool expects, two numbers and what kind of output it returns. In our case, the tool expects the input in float and also it gives the output in float. This isn't just good practice. The agent actually uses this information to correctly format its request when it decides to call the tool. Now, the docstring, the sentence in the triple quotes right under the function. This is generally the most important line in the whole tool. The agent does not read your code to figure out what a tool does. It reads the description. So if I had written a vague docstring like do math, the agent might get confused about when exactly to use it. Because I wrote something, add two numbers together, and we expect a result in return. The agent can confidently match it to a question like what is 1 plus 1 or 10 plus 10. The function body. Return a plus b. So here, return a plus b, and in the second tool, return length text split. Let's understand both of them. So the return a plus b simply returns the addition of two numbers which we have defined in our function signature. The text.split breaks a sentences in a list of words by spaces, and the length function counts how many are in that list. The agent does not care how the tool works internally. It only cares about the docstring, the sentence or the description of the tool. So and what happens inside the tool is a complete black box to it. Exactly like how we don't know what's happened inside the calculator circuit when we press plus button. Now we will add these two defined tools in a list in the last step. This is in the list. The list is what we hand to the agent next, basically saying that these are the only two things you are allowed to do it. Now the brain of our agent. So here, the chat grok function creates the connection to our large language models, and there are two settings. One, the model and the temperature. So the model Llama 3.370 billion versatile, it's telling the Grok exactly which open source model to run. As the Grok hosts several open source LLM, and this one is a strong general purpose choice. That's also good at reliably deciding when to call a tool, which matters a lot what we are building. Temperature equals to 0. The temperature controls how creative versus how consistent the model's answers are. On a scale roughly from 0 to 1 or higher, at 0 model is deterministic and predictable as it gets the same input, basically the same output every time. For an agent that needs to reliably choose the correct tool rather than get creative, low temperature is exactly what we want. If you were building something like a creative writing agent, instead, you would actually want a higher temperature like zero point 0.8 or zero point 0.9 or exactly 1. So let's let's assemble everything what we have discussed. So now let's look at the create agent class. So let's understand each argument. So here model equals to LLM. This this statement hands our LLM or brain to the agent. Tools equals to the list where we have added the tools which we created few minutes ago. So tools equals to tool statement. This hands our tools to the agent. So this list with our two tools function in it. The system prompt. The system prompt is the standing instruction for our AI agent. What it's expected to do. So this standing instruction is shown to the model before every single message in the conversation. Think of it as agent's personality and the ground rules set by us. We are keeping ours simple, like be helpful and actually use your tools when they would help. Here's the part I really want you to sit with. This one function call, create agent, it is call is building the entire plan, act, observe, repeat loop from video 1 for us automatically. Under the hood, the create agent is constructing a small graph, a flow where the model gets called, check if it needs a tool, call that tool if so, looks at the result and decides whether to keep going or give a final answer. A few years ago, you would have had to write a lot of looping logic yourself. Now the LangChain's latest updates collapses all of it into what you are looking at right now. So now before running our AI agent, a couple of things worth explaining before we hit run. Notice the shape of what we are passing into dot invoke function. A dictionary with a messages key containing a list containing one message shaped like role role of a user and content. This might look familiar if you have used any chat-based AI API before. It's the same basic list of messages with roles format that becomes the standard way of talking to LLMs. Role colon user just marks this message is coming from us, that is the human. The agent invoke actually runs the whole loop we just built, start to finish, and waits for the final result. That result comes back to us as a dictionary too, and result messages will contain this one will, uh, will will contain the entire conversation that happened internally. That is our question, any tool calls the agent made, the result of those tools, and finally its answer dot result message minus one. So the minus one just grabs the very last message in that list. If you don't write the minus one, you can trace the entire loop of our AI agent. So now let's see if our agent works or not. So now to run this agent, on the top right hand side, you can see this button run the Python file. Simply press it and wait for some time. And there it is. Look at that. It called the add number tool and gave us the answer. The sum of 42 and 58 is 100. And it also called the word count tool as well. So here see, the sentence the quick brown fox jumps over the lazy dog has 9 words in the sentences. So our AI agent combined both tools into one clean answer. That's the loop from video 1 which we discussed happened in right in front of you. It planned what it needed to do, it acted by calling the right tools, it observed the result and it gave us a final answer. No hard-coded if statements that is telling which tool to use. The LLM, the brain of our agent, decided on its own which tool to use, just reading the description which we defined in the tool. Now, if you want to print the full message trace, you can literally watch the entire loop, which I discussed earlier, to see how which to see each call tool. Sorry, my bad. To see uh, call each tool, see the result come back, and see it reason about what to do next. So now let's have a quick recap. So let's tie back to the first video, the four ingredients which we discussed there. The brain, that was our chat graph model, the hand, the two of our tool functions, the notebook. LangChain handle that internally tracking the conversation at it went. The loop, that was the create agent function running the plan, act, observe, repeat automatically. Same four ingredients, just real implementation, running code now instead of the diagram. So what's next in our series? This agent was intentionally tiny, two toy tools, nothing production ready. But now that you have seen the pattern, you can swap in any tool like a real web search, a real database lookup, a calendar API, and the mechanics don't change at all. In the next video, we are going one level up, that is line graph, where we stop letting the agent field decide everything and start actually controlling it flow like a flow chart. That's the step takes you from a cool toy to the production system. If you have understand this second video, please do subscribe my channel. Drop a comment telling me what tool you would want your agent to use. And also if you have any doubts, please be free to ask in the comment section. I will pick a few for a future episodes. I am Ashutosh Rane. This is Rane AI Lab. See you in the next one. And don't worry about the code. I will the GitHub link is in the description. Please go and check it out from there. Thank you.